This video is for Unit 5.3, and it's about right triangles, most of which are review. So if you recall, the sides A and B, which is right here, these two sides, are called legs. And side C, which is the longest side in the right triangle, it's called hypotenuse. Hypotenuse. So it's important to know the hypotenuse is opposite of the 90-degree angle in the right triangle. Also, a quick review of Pythagorean Theorem, and we use that to find the missing length, a missing side length on a right triangle. And the formula is a squared plus b squared equals c squared. Again, note that c has to be the hypotenuse, is the longest side, and a and b are just the legs. So some quick practices. We're given a right triangle and we're given two legs, and we're asked to solve for the hypotenuse. So if the equation should be c squared equals a squared, which is 7 squared, plus b squared, which is 8 squared. And it doesn't matter whether we call the longer leg A or we call the shorter leg A. The legs don't differentiate, but it is really important to note where the hypotenuse, where the hypotenuse is. And the hypotenuse, again, is the longest side of a right triangle. So you should have 49 here plus 64 equals x squared, and that should be 113, and so x should be square root of 113. You're welcome to leave it the way it is, as long as it's simplified, meaning 113 cannot be a perfect square, or there can be another perfect square in 113, or you can use your calculator and calculate it and give me an approximate of 10.6. Okay. Number 3, again, I have a leg here, and here the 13 is my hypotenuse, and I'm asked to find my other leg. So it should be the sum of the two legs squared, which is x squared plus 6 squared, should equal 13 squared. Notice the difference here. The 13 is the hypotenuse, and therefore this 13 has to be by itself. So a little bit of algebra. You should have x squared equals 133, and x comes out to be 11.5, and it's centimeters. Okay, so the rest of it is pretty self-explanatory. Make sure you pause the video and finish the other practices on your own. Now, let's move on to a really important concept. Again, make sure you get the concept, because this is where things get confusing, only because people don't know what each of these names, vocabulary words represent. Circumcenter is the perpendicular bisector of the sides of a triangle intersect at a point called circumcenter, meaning if I tell you that P is the circumcenter, then immediately you know that it's these PD, PF, and PE are perpendicular bisectors. Therefore, these two markers, tick marks, indicate the congruent parts. The circumcenter is always equidistant from the vertices, that's a V, vertices of the triangle. In other words, I'm going to use red this time. It's saying that from the P to the vertices, these three red segments are congruent. Okay, so let's look at below. List the perpendicular bisectors. Perpendicular bisectors, as we mentioned, we have PF, we have PD, and then we have PE. The name of the circumcenter is P, and we're also asked to list all congruent segments And congruent segments, I'm going to do this. I'm going to use blue, so it's for the congruent segments on the side. So AD and AB, I'm sorry, AB, AD is congruent to DB, and AF is congruent to FC, and BE is congruent to EC, right? Those are the congruent sides. And then I have from the circumcenter to the vertices, so I should have AP should be congruent to BP, that's a P, should be congruent to CP. So circumcenter to all the vertices are congruent, and just like where the red segments are in the diagram. Okay, so let's do one practice. Here it says if Z is the circumcenter of triangle TUV, so right here is the circumcenter, immediately I already know that these segments must be congruent. And also I must have right triangles, because it's circumcenter. It means two things. It means perpendicular. It means bisecting bisecting the sides. So we're asked to find each missing measure. TU, where is TU? TU is the whole length on one side. If I have XU being 19, TU is 2 times 19 should equal 38. VY, let's see, VY is half of VU. VU is 34, therefore VY has to be 17. UZ is from the circumcenter to the one of the vertices. Because it's circumcenter, so all the UZ, TZ, and VC has to be congruent. So UZ has to be 21 because VC is 21. Next one is a little tricky. WV, let's use red. WV is right here. So it's this segment here. Now, if I know TW, life would be easier, but I don't know TW. So let's look at this small right triangle. If I don't know WV, I want to call it X. And in this right triangle here, I have one leg and I have one hypotenuse. So in other words, I can use my Pythagorean theorem to solve for my X. And X should be approximately 14.7. Okay, so this one takes a little bit of observation, but everything you need is right there. And it's a little easier once you use color pencils to graph it out. TV, where's TV? TV, then you just need to multiply WV by 2, so I should have 29.4. Okay? So the rest of this is fairly similar. If as soon as circumcenter is given, you know that the sides are congruent, and then you also need to know you have to go look for right triangles. If you have right triangles, at some point, most likely you're going to have to use Pythagorean theorem to help you with solving these problems. So make sure you pause this video here and finish the rest of the practices before you move on. So this is the last concept of this unit. It's called the incenter. The incenter is the angle bisector. The angle bisectors of the angles of a triangle intersect at a point called the incenter. So if I know P is my incenter, that's what I mark out. It's all the angles are being split in half. The incenter is always equidistant from the sides of the triangle. So in other words, if I go from the incenter, let me use red. If I go from the incenter and then drop it to one of the sides, and then drop it to the second side, that's not a straight line, and drop it to the third side. These three segments are congruent. So again, reflect upon circumcenter. From circumcenter to the vertices are congruent. Incenter to the sides are congruent. So make sure that you understand the differences. Below here we have to list the angle bisector. The angle bisectors are PB, PC, and PA. The name of the incenter is P, and all the congruent segments, so I'm going to use red, PD, PE, and PF. Right? That's one group because of the incenter to the distance between the incenter and the sides. And let's see. Also, I'm going to use blue this time. Notice that AD and AF are congruent. BD and BE are congruent. CE and CF are congruent. So in other words, these two are congruent. These two are congruent, and these two are congruent. Now, why is that? I'm going to prove it with one set of triangles. So if you look at triangle APD, which is right here, APD, and triangle APF, which is right below it, right? Notice that both of them are right triangles because of the distance between the incenter to the sides. In the right triangle, they have a shared hypotenuse, so the hypotenuse is congruent. And also notice because of the distance from the incenter to the sides are congruent, PD and PF are congruent. Therefore, I can prove that I know that one of the legs are congruent. So by HL, these two triangles are congruent, and therefore the other leg, AD and AF, are congruent as well. Okay, so you can use the same method to prove the other pairs of right triangles being congruent and ensure that you understand that these congruency statements. So let's see how we can put this into practice. Example 1, if P is the incenter, that means this, and this must be congruent already, right? And also these are angle bisectors. So let's see. We're looking for MP. MP has to be 8 because it's the same distance. It's the same length as MP. NK. Where's NK? NK has to be congruent to OK. So it's 17. And PK. PK is right in the middle. So PK is a little bit more complicated. PK, we have to use Pythagorean Theorem because we already know MP equals 8 here, NK equals 17. So PK, if we call PKX, and notice PK is the opposite of the 90 degrees, so my PK is my hypotenuse, so x squared should be 8 squared plus 17 squared and x should be about 18.8. And LO is, you have to do the same calculation. So LO is 8 squared plus x squared equals 17 squared, right? So be very careful with, I've got my things written all over the place. So if you use a pencil, you can erase some of that so that you can see it easier. But the setup is the same. In this case, LO comes out to be 10.2. Okay? Finish problem number 2 on your own, and then I will do number 3 with you. So number 3 says, if S is the in-center, okay, then I know that these are congruent pairs of PQR, then the angle measure for PRQ, so this whole thing comes out to be, this whole thing is 8x minus 10. Angle measure of RPQ, so this whole angle P is 4x minus 14. And PQR, which is right here, is 7x minus 5. And I'm asked to find each missing angle. So this requires, it doesn't give us any specific angle measures. So it requires us to link this information with something we are familiar with. We know that if I just add all 3 angles together, I should have 180. So if I have 4x minus 14 is one angle. Then I add a second angle. Then I add my third angle, and I should have 180. Right? So that is 4, 7. So I should have 19x minus 29 equals 180, which is 209. And x comes out to be 11. So then the rest of it is just that I need to pluck each of this in. So this would be 11. So this would give me 78 degrees. And this would give me 72 degrees. And this would give me 30 degrees. Now I can start filling the blanks. The angle PQR is 72 degrees. Angle RPQ is 30 degrees. And, I'm sorry, I made a mistake here. This one is 78. It's PRQ. PQR is 72. I read it wrong. And RPS should be half because of the angle bisector. PQS is 36. PRS, by the same theory, is 39. And PSR, this one, I'll use a different color. I'll use gold again. So PSR is this angle, right? So we know that we know this angle is half of 30 degrees, which is 15. We know this angle is 39. So you have to use 180 minus 39 minus 15. So you should have 126 degrees. Okay? So that's how you do it. These things are not hard. The most important thing, again, is when you think about in-center, you think about angle bisectors. When you think about circumcenter, is perpendicular bisectors. That's the most important distinction. And then the rest of it is all old information that you can borrow and use and help you solve the problems. All right, guys, this is a rather long video, but make sure that you understand everything. And I'll see you in class. Bye.